This is measurement. If this is what measurement is, then it's obvious that the claimed measurement procedures in psychology as they arose in the early 20th century were not measurement, because we cannot concatenate levels of intelligence. We cannot assess whether two people are equally intelligent independent of the numerical assignments. We cannot set up this kind of procedure. If we add IQ scores to each other, the result is just added IQ scores. It says nothing about intelligence. If I put you into a room with another person and I let you solve a task, the product of your joint activity is not the product of the individual intelligences. I cannot open up your skull and see, independently of what the IQ test says, now I see you are actually equally intelligent as this person here, because here you have equal intelligences. I cannot do that. So it's obvious that whatever psychological measurement is, it's something else. And the situation got so bad, the arguments between the physicists and the psychologists got so bad that there was actually a committee. The British Association for the Advancement of Science, you know, we're talking, right, the Americans weren't even on the chart yet. Right? The Americans only got on the chart with the atomic bomb. In the Second World War, Americans were like completely irrelevant for science. Science was Germany and England. That was basically where science was, and a bit of France. That was it. And so the British Association for the Advancement of Science was sort of like the most important scientific organization in the world. The world was very small. Right? It was super Brexit world. And they actually set up a committee of important philosophers and physicists and psychologists to decide whether psychological measurement was actually measurement. Think about that. And so the committee deliberated and deliberated and deliberated, and there were arguments for, there were arguments against. This is, of course, it's obvious that these IQ scores say are not like these things, but you know, IQ scores, whatever you think of them, they have tremendous predictive power. They predict a lot of things pretty well in life. How well people will do in school, how well people will do in all kinds of situations. They predict life outcomes, and they show lawful behavior. The positive manifold is a real law of psychology. You will not succeed. Actually, careers were broken on attempts to produce cognitive tests that are uncorrelated in the population. It's not possible. So there's a lot of lawfulness in that, and the psychologists said, well, hey, you know, lighten up a bit. This is also numerical representation, it's also interesting. But so they didn't actually get out of this, and they never actually made a verdict. And if you want to know more about this, you should read the beautiful book by Joe Michel, Measurement in Psychology, Critical History of a Methodological Concept. Really beautiful book that details this whole affair. And just to give you a flavor of the things that were being said, this was a particular hardliner in the committee who said to insist on calling these other processes, like, you know, IQ test measurement, adds nothing to their actual significance, but merely debases the coinage of verbal intercourse. Beautiful sentence, by the way. Measurement is not a term with some mysterious inherent meaning, right? Part of which may be overlooked by physicists. I mean, the very idea that physicists could overlook something, right? And maybe in the course of discovery by psychologists. No, you know, measurement is what measurement is. Period. So, conundrum, difficult thing. So this guy here, this is SS Stevens, this guy was more or less on the line. He was an experimental psychologist, and he had produced a lot of skills that he claimed were measurements. And actually the committee had used one of his skills as an example, you know, and they had smeared that for his, he thought about it long and he thought about it hard, and he wrote a paper that's called On the Theory of Skills of Measurement. And it was published in Science. And in my view, this is the most influential thing any psychologist ever did. This is more influential than Freud or Skinner or all these people. You've probably never heard of Stevens, but this paper has affected each and every single line of statistical analysis and methodological investigation. This has steered the development of statistics. This has steered the development of measurement theory. This paper is by and large the reason that you are learning the things that you are learning about the relation between measurement and statistics. And in this paper, he invented, it's also an important point, they didn't exist. It was not like there were always scales of measurement. You know, if you had told Spearman, well, you know, I think your measures are really ordinal and not interval, he would have, huh? That didn't exist. Stevens invented these scales. And so he said, you know, Campbell is right. This is measurement. It is a process of representing empirical relations by numbers. But it's not the only kind of relation you could choose to represent. This is a very specific quantitative set of relations. But maybe I would want to represent other kinds of relations. Maybe I would want to determine only the order. Maybe I just want to have numbers that only reflect which things are heavier than another and not the exact differences between their masses. Maybe there are also numbers that are just served to indicate equivalence. I could give all the blonde people the number 0 and all the brown-haired people the number 1. That doesn't mean the brown-haired people have like more color. It just indicates equivalence. So, by Campbell's own terms, this is what measurement is. So Campbell's measurement is but one kind of measurement. And that was and this gave rise to the idea that measurement comes in different scales. Ordinal, nominal, interval, etc. And this is then the ratio scale. So this is a pretty brilliant move, also a controversial move. I personally admire this move. I think it's very clever. But there are also people who think that Stevens, you know, he had go away. It's the director of research. Yeah, but apparently there's something wrong. Sorry. So anyway. Back to something important. So we have different kinds of scales that represent different kinds of relations, and these are the scales that you know. A nominal scale only represents equivalence, and the paper you've read, ordinal scale, the numbers only represent order, and interval scale, then the numbers not just represent order, but also the differences between the assigned numbers have definite meaning. So the difference between, an example is a scale in Celsius, temperatures in Celsius. The difference between 0 degrees and 1 degrees is the same as the difference between 30 degrees and 31 degrees, so that the meaning of that unit is maintained. But the 0 point is arbitrary. And you have a ratio scale. And this is the strongest scale type. In a ratio scale, or the one next to strongest scale type, not just the differences have meaning, but also the ratios. So the degree to which this is heavier than this also has meaning. Or the 2/3 also has meaning. I'll get back to that in a while. So Stevens' response was, okay, you have your ratio scale, physicists. Very good of you. And it's a nice life if you have ratio skills. We don't have ratio skills, but we definitely have ordinal skills. Somebody who makes more IQ items correctly is more intelligent than somebody who makes less items correctly. You may of course disagree with this, but that was his argument. And some skills actually approximate the quantitative structure, and they may have sort of interval properties. So for instance, I wouldn't maintain that the IQ difference between 130 and 131 is exactly the same as the IQ difference between 100 and 101. I don't believe that. But I do have an intuition that the difference between, say, 115 and 150 is larger in a meaningful sense than the difference between 100 and 101, right? So these differences aren't truly completely quantitative, but they're not entirely simple orders either. So anyway, the question now is not, do I have measurement or not? Basically, as soon as I have a systematic way of assigning numbers to objects or persons, I have measurement. I just have a question what my level of measurement is. And that's something we can investigate, theorize about, etc. So measurement is possible after all. And this is Joe Michel, and he doesn't believe anything of this. So if you are critical about this, you should read him. Really good. But Stephen's line was that measurement is possible after all. And he also offered a formal definition about these skill structures, and few people know this, but this is an important issue. What you can do with the assigned numbers without breaking the mirror, that determines the skill level. So if I have 0 and 1 for the blonde and the brown-haired people, I could also give them 31 and 655. It wouldn't matter. It would represent equivalence equally well, right? So I can use any transformation from the original numbers to a new set of numbers, as long as everybody gets the same number if they had the same number. So that's called a 1-1 transformation. And each of those is admissible in a very specific sense, in the sense that it keeps on representing the world just as well as it originally did. You can imagine that, right? For an ordinal skill, I cannot do everything with the assigned numbers. But I can do a lot with them. For instance, I could square these numbers, and it would still represent the order, right? Then this would get 1, and this would get 4, and this would get 9, and this would get 16, and this would get 25. And still, a higher number means a higher order. So I could do that. I could do that. With an interval skill, I cannot square the numbers just like that. Then things get broken. Then things no longer represent what they used to represent. So, and that's also the case for a ratio skill. So for an interval skill, I can linearly transform values. That means I can add something to them and multiply them with something, and I will still get the same representation. And for ratio skills, I can multiply them with something, but I cannot just add something to them. Then things will be broken. And what do I mean by broken? This is what I mean by broken. If I did what I just did, right, I transform according to the rule, the new x is the old x squared. So here I get 1, here I get 4, here I get 9, here I get 16, and here I get 25. Then the original relation that we had, namely that this one and this one balance this one, no longer is mirrored in the quantitative relations, right? Because this one now has the number 4 attached to it instead of 2. And this one has the number 9 attached to it. And this one has the number 25 attached to it. And obviously, sorry TB, obviously 4 plus 9 is not 25. See? So that beautiful mirror I constructed that showed me the relation, the quantitative relations in the world based on through the lens of the numbers is now broken. So for a quantitative scale like this is a ratio scale, I am not allowed to do this. Because if I do it, if I use this, I lose something. And that's what it means to have a ratio scale or an interval scale. It means I disrupt the mirroring of the world when I use certain transformations. So, the stronger the scale level is, this is something that very few people, if you know this, you can really make a great impression at drinks with methodologists and psychometricians. Few people know this, and you'll probably forget it when you walk out of here. But it's a really, really nice thing. The stronger the skill level, the less you can do with it, because it contains more information. So you cannot do a lot with ratio skills. Your hands are tied. But with ordinal skills, you can do all kinds of things. You can square them. You can take the square root, or you can take the exponent, or whatever. You can go to the mathematician and give me the weirdest transformation that still maintains the order, and you can just apply it, and they will all be just as good. All of them. Because all we represent is order. In psychology, why would you want to do that? Well, because you, for instance, want to have an ordering of people in terms of intelligence. So you want the higher scores to represent a higher intelligence.
Why would you multiply it or divide it or
Why would you multiply? Why would you divide things? Why wouldn't you just let the scores be? You know, just let them be as they were. Okay, yeah, well, that's okay. So you do that. You do that. You are the new numerical naturalist, right? You say the numbers are what they are, and we will let them be. And now you go do research, okay? So you want to do research, say, on whether males are more or less intelligent than females, or something like that. Or you want to investigate whether some brain training improves your intelligence, right? Okay, so you got two conditions. You got scores here and you got scores there. And you want to know the difference between the conditions. Whether the brain training program has effect. What do you do? Sorry? You compare the two sets of scores with what? With eyes? With your eyes?
with each other.
Yeah, but how do you do it? What do you do? You got a set of scores here, set of scores there. How do you compare the means or the distributions or? Yeah, well, no, okay. Well, with a statistic, what kind of statistic? A mean, for instance. And then you would say, well, see, hey, my mean in the brain training condition is higher than my mean in the non-brain training condition. I've got an effect. But then I say, it's just coincidence. So what do? You see if the means differ significantly. And how do you do that? With a t-test. Okay. So, here our naturalistic numerical assignment, naturalistic measurement theorist has found a significant relation, right? So you say, I'm going to be rich, I'm going to sell this brain training program to all kinds of people because it works. Because there's a significant difference between the experimental condition and the control condition. But now I come, right? And I say, okay, here are your scores. Well, I think they just, do you think they're quantitative? I think they just represent order. You know what I'm going to do? I'm going to square them. And I do. So I take all your numbers, I square them, and I run a t-test too. What do you think I find? I will find something different. Yeah. I will find a different p-value. And my p-value is not significant. So now you have a problem. Because you say there's an effect of my brain training program. And I say if I square the scores, effect goes away. And you know, what do you want to do? What do you want to do about it? Why would I not be allowed to square the scores? Because it breaks the mirror. Yes, exactly. It's a skill. You can't just do that. You're not allowed to do that. Right? Because it breaks the skill. But now I have a defense. Right? If that's what you're going to say, if you listen to him, I don't know if you should, but if you did, then you have a new problem. Because then I say, what mirror? And then you have to say, well, you know what? These scores are at the interval level of measurement. That's my defense. Right? So, and that's the whole point. That's the reason. If I have a set of scores and I have two means in my here the green ones are the non-brain training ones and the red ones are the brain training ones, I can in the upper situation I would have the mean of the red ones equal to the mean of the green ones, but if I transform them I can change that. So I get different p-values as a result of changing the distances between the scales. So nonlinear transformations are transformations that will change one's compute conclusions. And if you don't believe this, you can just do it at home. Actually, everybody is running all kinds of complicated programs here, so you can actually do it in Excel. Just take two rows of numbers, do a t-test, then square the rows of numbers and do a t-test. You will see different p-value. And that is the reason that people think that ANOVAs depend on skill levels. Because if you transform the data such that the distances between the skill points change, which you are allowed to do for an ordinal test, ordinal measurement, then you change the relations between the skill point and therefore you change the conclusions. And if you change the conclusions, why shouldn't you be able to do that? Well, because the data are at the interval level of measurement. So, what we have here is like a life belt. The idea that you should not do t-tests on ordinal scales doesn't arise from the fact that you will be locked up if you do that, or something bad will happen to you. It arises from the fact that if you limit your t-tests to interval scales, you are never susceptible to this kind of charge. Right? So if I use, for instance, a non-parametric test which doesn't depend on the distances between the scale points, then you can never come to me and say, well, I'm going to transform your data and square them and your effect will go away. Because then I can say, hey, my effect doesn't depend on the exact scale values. You can do all your transformations and the effect will not go away. So you have a life-saving belt.